All right, welcome. This is week 11. We have Tuesday, October 15th homework here. It says the graph shows the rate in which Tom, it should be Tom, travels on his bike. Okay? All right, and here's time in the x-axis and distance in the y. All right, with the line traveling through the point 5, comma 45. Ooh, let's just put that in the point here. Okay? So 5 here. This is 545. Okay, so the x is 5 and the y is 45. All right, which equation can be used to determine the value of y for the given x? Oh, here are the equations. It seems like we should just compute the slope first. Okay, let's get the slope here, or the rate. All right, and we know that the slope m is defined as the change. I think I make that blue, yeah, the change in the y, divide that by the change in the x. All right, so how much is the x changing by? So if you want to write this in the other term, let me show you how this would look like the other way. Okay, it would look like where this, the change of y is just the what? Second y value, which is y2 minus y1. Well, that would be the change of the y. And let's do, oh, let's do the change of x, which is going to be, oops, that would be x2 minus x1. Okay, what is it? What is x2? So the first point, it's very beautiful because proportional relationships will always start here on 0, 0. All right. So what is y2, which is the second point right here, which is 45. All right. You write here 45, and the first value was 0. So this just becomes 0. So it goes away. All right. What is x2? That looks like it is 5. So let's erase this and let's put the value 5 right here. And then we minus this. What is x1? Which is 0. There you go. The slope is 5 over 4, which can be simplified if you plug in your calculator. I know it can be simplified into what? You pull out a 5 above here, which is just 7. And the bottom would be 1. That is the slope, 7 over 1. What is equation we should determine the value of y for a given value of x? Did I type this in wrong? Oh, haha. I did type this in wrong. It's 45 over. So what they did here. Let me show you. So there's an error here. So this formula is y equals mx, right? And mx. But we know that the slope, which is m, right here, is what? 4 over 5. So slope is 4 over 5. So that's the equation, 4 over 5. The answer should have been A right here because it's 4 over 5. So there should be a divide by 5 here. All right. So, or you could wrote it as 7 over 1, but they don't have a 7 over 1 here. Okay. So it should be 45 over 5x, or you could have seen it as this equation. You could also have seen it like this as well. You could also have seen it like this using 7 over 1. You could have seen it like this. Oh, okay. You could have seen it like that. 7 over 1 x. So these are your two equations basically. Okay, what is the constant proportionality in the graph? This is a bad word. Constant proportionality, right? Your constant rate. This right here is just another word of saying what is your slope. So what is your slope in the graph? You could say it is either 4 over 5 or you could say it is what? 7 over 1. Okay, these are your two slopes. Good. That's basically how much Tom is riding by. So Tom rides at 7 out. Wait, how much? What is it? 7 miles in 1 hour. Or you could say Tom rides 45 miles in 5 hours. Okay. Using the graph to the right, which is this one, you're going to complete the statement about the relationship between the two triangles. Okay, we would say triangle ABC. What is this triangle here? Does anybody know what this triangle is? Triangle ABC. Let's look at it. Where's ABC? A, B, C. Oh, so it's this triangle. That's that triangle. Okay, and CDE. Let's color code that. Where's CDE? It looks like it's right here. So C, D, E, and close it right there. Good. Okay, A, C, D are blank because their sides are blank. Or what? Or what? Oh, they're not the same size, but they are the same shape. When they are, remember, they are, let's just write this. The two triangles are the same size, or the same shape, but not the same. The two triangles are the same shape, but not the same size. All right, do you agree? They're both triangles. They're the same shape. Are they the same size? No, one is smaller. So, what word do we use with that? We would say they are, if I know how to spell it, hopefully, similar. I think that's how you spell it. Okay? Similar. Because their sides are, you could also say their sides are, you can use that word, I think, proportional. Okay? All right. What is the ratio of the length of the sides of the vertical side to the length of the horizontal side? So you want a ratio. Okay, you want a ratio. So let me just get this one off. You want the ratio right here? Ooh, let's set up this ratio. This is very interesting. So a ratio of the length of the vertical side to, which is, that's the divide symbol, right? The length of the horizontal side. So you want to set up a ratio, and there should be a bar right here. Okay. So on top is the length of the vertical side. The bottom is the length of the horizontal side. So let's get triangle ABC first. So triangle ABC. What is the length of the vertical side? The vertical side is the up and down part. So how much is it going up by? Looks like it's going up by 1. So we would say it is 1 divided by, how much is the horizontal side? 1, 2. 2. Okay. Now we want to grab CDE. What is CDE's ratio? Let's count that. So the length of the vertical side. The vertical side is the up and down. So this is 1, 2, 3. So that is 3. Divide it by the horizontal side. Let's count that. 1, 2, 3, 4, 5, 6. 3 over 6. Okay. So, 3 over 6, that can be simplified. If you put it in the calculator, you get 1/2. Because you could divide the top by 3 and you could divide the bottom by 3. You could pull out a GCF of 3 basically. Okay? Ooh, they're the same. This is interesting. So, what is the ratio of the length formally formed using a section of the line shown as the hypotenuse? All right. So, we would say the ratio is basically what right here? It is basically 1/2. 1/2. Okay, 1/2 here, 1/2 here. Write a statement that explains how the rate of change is represented by this graph. What is the rate of change? Okay, what is the rate of change? We want to look at this rate of change here. So the rate of change is that it is what? Changing. So the length of the vertical side is what? Is changing by how much? By how much is it changing by? The vertical changing by 1 unit. Okay, could be anything here, but we're just gonna say unit. Okay, and the length of the horizontal side, okay, is changing by how much is the horizontal part? That looks like it is changing by 2 units. Okay, there you go. That is what you would say. That is the rate of change. The length of a vertical line is changing by 1 unit, and the length of the horizontal side is changing by 2 units. That is how you would describe this graph right here to the right. Okay, so there you go. Those are all the solutions for Tuesday, October 15th.